having radioactivity. Radioactivity is a spontaneous decay or disintegration of the unstable atomic nuclei with emission of alpha, beta, and gamma radiations with release of heat or energy. That is radioactivity. It was in 1896 a French scientist, Henri Becquerel, discovered that the uranium atom can disintegrate with the release of alpha, beta, and gamma radiations. He also understood that or discovered that X-rays could penetrate a paper and similar opaque materials. It can penetrate through a paper and similar opaque materials. Marie Curie also in 1898, she discovered that radium is even more active than uranium. It is more active than uranium in releasing such radiations of alpha, beta, and gamma rays or gamma radiations. So such elements like uranium, radium, and thorium that can disintegrate or decay with release of heat or energy together with emission of radiations like such as the alpha, beta, and gamma rays is called radioactivity. It's called radioactivity. So elements such as uranium, radium, and thorium which emit such radiation are said to be radioactive. So the elements that exhibit such radiations or that emit such radiations are said to be radioactive. So this is deflection of particles or radiation in magnetic field of radium sample. This experiment was conducted using radium sample. This is a lead block. The radium sample is inside the lead block, and under magnetic field we have the south and the north pole of the magnet. This is positive and this is negative, and there is emission of alpha, gamma, and beta. So the alpha is slightly deflected. The alpha is slightly deflected while the gamma is undeflected and beta is strongly deflected. So that is what happened under the magnetic field. When it comes to particles in electric field, the radium sample of using the radium sample applying electric field. This is lead block. There is alpha, gamma, and beta. This is negatively charged. This is electrically charged, positively charged. So alpha is slightly deflected, gamma is also undeflected, and beta is strongly deflected. So when both the electric and magnetic field were used, the alpha was slightly deflected, gamma was undeflected, and beta was strongly deflected. So this is the deflection of particles in electric field. Deflection of particles in electric field. So deflection of particles in electric field, deflection of radioactive radiations, which is in A magnetic field and B electric field. So that is the two type of experiments that were conducted. And alpha, beta, and gamma radiations are represented symbolically as helium with a atomic number 2 and the mass number 4, and this is beta with 0 minus and gamma with 0 0. since they are it is undepleted respectively. So an element of atomic and mass number Z and A, which it disintegrates by the emission of alpha particles, is transformed into another element of atomic and mass number Z minus 2 and A minus 4. So this is what's radioactive, what's the meaning of radioactive, and the experiments conducted in radioactivity using magnetic and electric fields, and how alpha, beta, and gamma are represented symbolically. So that is how the particles that are emitted are represented symbolically. Alpha as helium, with atomic number 2 and the mass number 4, and beta particles with -1, 0, and -1, and gamma with 0, 0, since it is undepleted. So that is what we have today. So we call it a day.